Hi guys, and welcome to my YouTube channel La Fisica che ci piace, where learning physics and mathematics, it's okay. Let's continue to talk about the 18 biggest unsolved mysteries in physics. This is actually the third part. If you want to watch the first part, click here. If you want to watch the second part, click here. Okay, let's go. CP symmetry. CP symmetry. If you swap a particle with its antimatter sibling, the laws of physics should remain the same. That's the principle of charge symmetry. If you swap left and right again, the laws of physics should look the same. That's parity symmetry. Together, the two are called CP symmetry. Most of the time, these physics rules are not violated. However, exotic particles violate this rule. But why? Sound and light. Sound and light. If you take some water and heat it with sound waves, bubbles will form. The outer pressure pushes in on the lower pressure air, and the bubbles quickly collapse. When those bubbles collapse, they emit light in flashes that last a trillionth of a second. It's far from clear what the source of the light is, though. Standard model. Standard model. The standard model that describes the behavior of the particles is one of the most successful physical theories ever devised. It's been standing up to experiments to test it for 4 decades, and new experiments keep showing that it is correct. The standard model doesn't explain everything, though. There are several contenders for new, more complete models. String theory, for instance, is one such model. But so far, none of these have been conclusively verified by experiments. Constants. Constants. Unlike the speed of light, dimensionless constants have no units, and they can be measured, but they can't be derived from theories, whereas constants like the speed of light can be. Physicists would love to figure out why those particular numbers have the values they do, because if they were different, the universe's physical laws wouldn't allow for humans to be here. Gravity. Gravity. What is gravity, anyway? Other forces are mediated by particles. Gravity doesn't seem to be like that. Most physical theories say it should be carried by a hypothetical massless particle called graviton. The problem is nobody has found gravitons yet, and it's not clear that any particle detector that could be built could see them, because if gravitons interact with matter, they do it very, very rarely. So seldom that they would be invisible against the background noise. Vacuum. Vacuum. Vacuum, or empty space, should be the lowest possible energy state, because there's nothing in it. Meanwhile, the Higgs boson gives everything its mass. The energy state of the vacuum can be calculated. So far, those calculations appear to show that the universe's vacuum might not be in the lowest possible energy state. That would mean it's a false vacuum. If that's true, our universe might not be stable, because a false vacuum can be knocked into a lower energy state by a sufficiently violent and high energy event. Okay guys, see you next time. Bye!